So for the first problem, how many, how much does the entire cost? The problem says that we define an integer to be the most common in a subsegment. Basically, let me use this. So we will be given an array. We will be given an array of length n and an integer k, and we have to tell if there is like inside this array, if there is any subsegment such that the occurrence of this character k, or maybe you can say frequency of this array k is greater than the frequency of all other elements. So if this is a case, in that case, we will say that this element k is the most frequent element inside the subsegment, like whatever word they used. And we have to tell if there is any subsegment such that k is the most frequent guy there. So for that, we can just say that if k comes in the array at least once, at any place whenever it comes, I will just pick up this element as the subsegment where only this guy is coming. So it is the most frequent guy. And my answer will be yes in that case. And I can always have it. It doesn't matter how many times k comes and where does k come. What matters is that whether k comes in the array or not. If it is coming, then answer is yes. Otherwise, answer is no. Right. Uh, did you guys understand this? Just yes or no? Does this make sense? Yeah, makes sense. So let's look at the code, and maybe you can look at the examples during the contest. When you get this approach, you can look at the examples that here we need 4, 4 is coming, and the answer is yes. For the next test case, 1 is not coming, answer is no. For the next test case, 6 is not coming, so the answer is no. And in all the other test cases, the element k is coming in the array, and the answer is yes. And that's what my approach was. So what I did here was to just take the inputs and then run a for loop and said that if at any point I find k, then I will return yes and I will just return. Otherwise, at the end, I will return no. As simple as that. For the second problem, it says that you will be given an integer n. You will be given one integer n, which can be as large as this. And you have to form an array A such that it is strictly increasing, which means that every element should be larger than the previous element. I think it should have been mentioned somewhere. No, it's not mentioned, I guess. Anyways, and there is one more condition that thrice of a of I plus 2 is not divisible by a of I plus a of I plus 1. What it means is that inside the array which you form, for any a of I, it should be greater than a of I minus 1 unless I is equal to 0. Like for all elements except the first element, it should be larger than the previous element. And for all elements with I greater than equal to 2 for zero-based indexing, it should not be divisible by, if you divide it by like 3 into AI, or maybe let me just simply write it. AI should not be divisible by, sorry, 3 into AI should not be divisible by uh, a of I minus 1 plus a of I minus 1. Right. In the problem, they have been taking it I plus 2, a of I and a of I plus 1. But you can take it in this way also, that for any element, its thigh should not be divisible by the sum of the previous two elements. And for this, there can be multiple patterns which you can form. The pattern which came to my mind was this 1, 4, 7, 10, 11, not 11, but 13. Yeah, 13, and so on, which is nothing but 3 of k plus 1, where k is any whole number. And the simple thing was that any, like, if you take up any three consecutive elements, three of k plus 1, 3k plus 4, and 3k plus 7. And just say that their sum, like the sum of these two elements will be, yeah, the sum of these two elements will be 6k plus 5, and the price of this element will be 9k plus 21. Now you can check that this value is always going to be small. The twice of this value, which is 12k plus 10. Basically, if this is a divisible, like if this is a divisor of this element, in that case, was some multiple of this element should be equal to this. For that, you can just check for one, two elements, and then you will see that it's never possible. So, if you try this, 12, was this an observational problem? Maybe there could have been some observation. In my case, I just randomly thought, what if I have a pattern where all elements are at a difference of 3? Because the thing which I wanted was that I knew that thrice of this element is going to be divisible by 3, uh, a multiple of 3, you know, multiple of 3. And if I could have these, like these elements, 3k plus 5, it is certain that this is not a multiple of 3. And like you can try to figure it out, but you will always find that if there is a number which is not a multiple of 3, not a multiple of 3, and divide it, what's this? Yeah. Uh, Find the remainder of that number with a multiple of 3, you will always get some remainder. The remainder won't be 0, which means that a multiple of 3 cannot divide a number which is not a multiple of 3. Like pretty common sense also. And in this way, I could come up to this sequence. And for every value of n, I just printed the n elements of this series. If we choose all odd numbers, odd is odd and odd is odd, I will go without this. That is odd is odd. Oh, yeah. This pattern will also work. But if you take something like 1 plus 3, like 135, like there can be many patterns. The thing which came to my mind first was this one. You could have picked up this, that all elements are odd, so odd plus odd will always be even, and odd into odd, like 3 into odd, will be odd, and odd can never be divided by even. So in that case also your series will work. Right. So I think that this problem should be clear to you. This was more of a constructive algorithm problem. Okay, great. So let's see the solution. The code is pretty simple. I'm just taking the input n and printing a loop, like running a loop to print all these elements. That's it. Let's move on to the next problem. In the third problem, it says that you will be given some three variables, like you will be given three variables, n, k, and x. Just a minute. Yeah. So you will be given three variables, n, k, and x. What you have to do is choose some k variables from 1 to n, like choose exactly k variables. Sorry, not variables, but k integers between the range 1 to n, and you want their summation, like the k elements you choose. Um, let's say you chose some element x, I. So the sum of all these elements should be equal to x, something like this. Now this is somewhat like a standard problem um, used for easy problems, where you could have noticed that, let's take an example when n is equal to 5 and k is equal to 2. So you have to choose from 1, 2, 3, 4, 5. The minimum sum you can create is 1 plus 2, which is 3. And the maximum sum which you can create is 4 plus 5, that is 9. And now my claim is that in the range from 3 to 9, you can make any sum. You can take up any combination so that you will be able to find all the create the sum of like any elements. Let's say if x is equal to 6, so you could have chosen something like 1 plus 5. If x is equal to 7, then 2 plus 7. If x is equal to 8, then 3 plus 5. X is equal to 9 के लिए you could have chosen 4 and 5. And similarly for x is equal to 5, 4, 3, you could have chosen some values such that you will be able to find all these as sum. So the logic was pretty simple here for this, that you can just find the minimum sum which you must have. Let's create it as min sum. The min sum is simple. Like let's declare you have a function sum in which you will pass some variable integer n, and it will return you the sum of first n natural numbers. Let's say you create a function like this. So the minimum sum is gonna be equal to sum n k, and the max sum you can have is gonna be equal to sum n, like the maximum elements you could have picked. But if you pick up just all the elements, and now from this, just subtract the sum till this for finding the sum of last two elements. So you can say sum of n minus sum n of n minus k. This is the third problem. This is C problem. Now, when you have found the min sum and max sum, you can just say that, hey, if x is greater than equal to min sum and x is less than equal to max sum, it means that it is lying inside the range, and thus you will be printing yes. You will just print yes and then otherwise just see out no. Okay. Will they give some in k integers only? Uh, yeah, basically you just had to return yes or no. And the claim is that if you can, like if your x is belonging in this range, then by just increasing or decreasing some values of the numbers which you are choosing, you will always be able to form the number. Now, I'm not proving the solution like claim here because this is something standard and you can try this on your own. Uh, as I have to cover the non-standard part here mainly, that's why I'm not covering the proof, but you can logically prove it very easily, and you can do some dry run to convince yourself. For example, there should be some of the integers. Yeah, for this, the k was 2, but if you pick up something like n equal to 5 and k equal to 3, you will again, like you will still be able to create all the elements system. You can try this. Like when I was a beginner, I did try this and I could prove it, so it's not that hard to prove. Now, once we have found the min sum maximum, check then just return the answer. So let's see. Here we can say that just take up n and k as input and this x. Yeah, by the way, remember that x could have been large. That's why we have been taking it as long term. You could have taken it as long also. And I created a function. This is a lambda function which will take an integer as input and return the sum of first n natural numbers. And there I have, and then I have here like two variables, min sum and max sum, the minimum and maximum sum I can create. Then I'm just checking if x is inside the loop or not and returning yes or no, printing yes or no on the basis of what I get. So I hope that it's clear to you and we can move ahead. Just write yes or no inside the chat once. It shall we move on to the next problem? Okay, that's good. Okay, Tanisha, you want me to explain the questions again? So for this, like there is some standard stuff. Yeah, after the C, I will be explaining the E problem first and then the D problem. Like E1 is pretty straightforward if you know about the concept. I will be using a segment tree. So if you know what segment trees, then this is pretty straightforward. and B is a little bit uh, observational. Okay, so here the idea was that if I just pick up the smallest k elements, in that case I will have the min sum, the minimum sum I can generate. If x is less than min sum, then definitely my answer is no, right? If the value of x is less than the minimum sum which I can generate, then my answer is definitely no. Similarly, I can find the maximum sum I can create by just picking up the largest k elements. And I can say that if the x is greater than max sum, then the answer is still no. Now my claim is that in all the other cases, when x is inside the range from min sum to max sum, you will always be able to uh, pick up some k elements such that the sum is equal to the range, and your answer will be yes. This is my claim. And just for simple proof, like a very simple proof, if you know about generating all subset sums, or I think that it's not a very relevant thing. Um, Maybe you can do some drawing for this. Every problem from minimum to maximum solutions. This is hard to come up. I think it's not very hard to come up though. Like you can just think of any x and just pick up any key elements. If it is inside this range, like if x is inside that range and the key elements you picked up have a some y and y is less than x, then in that case, the elements which you picked, you can just increase their values by 1, 1, 1. You know, you can just increase the value of any element by 1. And you can do this until your y is like, as long as your y is less than equal to maximum, you can increase it. At some point of time, either y will be equal to x or this state will come, and it will actually come only when x is greater than maximum, where we are just returning no. So like this is the logical proof that if you pick up any k elements and the sum is y is greater than x, then just start picking up smaller elements. The elements which you have picked up, let's say you picked up 1, 2, and 7. So just reduce the value of any element which you can reduce to 6, maybe reduce to 5, 4, and so on till you have the smallest three elements. And at some point of time, you will definitely have the sum x as you are just able to produce all the subsums. I think that it should be clear now. Okay, great. Let's see the D problem. Yeah. Sorry, E problem first. So the E problem, what it says
Can you
is,
please show the code for C?
uh, what did you say?
Can you please show the code for C?
Okay, okay. For C, what I've done is just take inputs. I created a function so that I will just pass on a variable and it will return me the sum of all integers still there, sum of all natural numbers still in. And I'm saying that the minimum sum I can have is sum n of the first k elements, and the maximum sum is the sum of first n natural numbers minus the n minus k natural numbers, so that I will be just left up with the largest k numbers which I could pick inside this range. If x is inside this range, then yes, otherwise no. Simple as that.
Okay.
Yeah, let's move on to E now. Okay, so in E, what it says, I think that there were some queries in this problem. Yeah. So what happens in this E problem is that you have been given an array is being given to you, and we have been told that there is something like f of L and R, like a function which will take two parameters L and R, and it will return you the and of and of all the numbers, bitwise and of all the numbers inside this range till R. And we have been given some queries. In every query, there will be two things, left and some k. Basically, you can say L and k. And you have to pick up, you have to tell the rightmost, like the, the largest value of R which you can have, such that, like, which satisfies that f of L comma R is greater than equal to k. Is this clear? And in case if there is no R which satisfies this, which means that uh, you will not have any R in case if array of L is just smaller than k. This is gonna be the case when it will not be possible. So in that case, you have to return minus. So is it clear? Just write yes or no inside the chat. Right. Is it clear? Okay, great. Uh, yep, I can repeat it fast once again. So you have been given an array. You have been given an array, and you have been told that a function taken from L to R means that uh, like if you just put up L and R inside a function, it will return you the bitwise and of all the elements in this range from L to R. You have been given some queries. In every query, you have been given two elements, L and R, L and K. And for this query, you have to tell the rightmost value of R, the largest value of R, such that f of L comma R is greater than equal to K. And in case if there is no R which exists such that f of L comma R is greater than equal to K, then you will return -1. And I just told you that this case will happen only if the a of L is less than K, because if a of L is greater than or equal to K, then you can just pick up R equal to L and you will have f of L comma R greater than equal to K, at least for this element. But if you are not getting it for any element, it means that a of L is also smaller than K, though it's not a problem right now. Now, what you can do, like a very simple way of doing this problem, could have been to no, prefix some wait, prefix and don't work, I guess. You can use something like a segment tree, sparse table, or even a Fenwick tree. If you use these data structures, in that case, doing this problem will be very easy. I used a segment tree, and for the segment tree, what I did was to store the uh, and result for all the ranges. I left this problem with one. Yeah, though actually this problem I think can be solved without these data structures also, but it would become complicated. With the data structures, it is very simple. And yeah, then we will apply a binary search. So what we could have noticed was that if the left is fixed, and you pick up this range, and let's see what some result like result one as the bitwise output, or let's say f1. F1 was the result of the bitwise and of all elements in this range, and you applied it for this range f2. Then my claim is that f1 will always be greater than or equal to f, because doing bitwise and can either make your result smaller or just remain as it is. So A and B equal to C. If this is the case, then A will either be greater than or equal to C, and B will either be greater than equal to C. C can never be larger than any of these two. It will always be either great equal to them or smaller than them, which means that this I can have something like monotonically decreasing array. If I just try to see that what will be the output of this range, then it would be smaller than the output of the range of the smaller range. So I just have to find the rightmost element such that the result I get is greater than or equal to k. Does this make sense? That this is just simple binary search. If you know about binary search, it should be easy to understand, right? Like this part should be easy to understand. Please confirm it once. Is it clear or not? Okay, that's great. I don't know about prefix. So like I've not tried it with prefix. So sorry, prefix and I've not tried with it. Sec3 is something you can study. Like Sec3 is a pretty easy to understand topic, even if you don't if you're not able to understand it properly with the approach, even if you are not able to do it at your level, still you can understand how to use the template and you can still use it with copy pasting it. Clear, but don't know segment trees. Can you tell some resources? Yeah, for segment trees, you can watch Stiver's video on his channel Take You Forward. So he uploaded a video there. It has lazy propagation also. And then there has been uh, CP algorithms. I think this much should be enough. And even the EDU section is very good. And for the template stuff, you can pick up my template of segment trees. Okay, so now let's come up to this problem again. For every query, you know about the left element. You just have to find the rightmost element such that f of left right is greater than the given k. And in case if this condition holds, then you will mark this as your answer and search for like search on the right side. So you will search in this space then. And in case if it fails and you'll get a no, in that case you will search in this range. Simple binary search. So if it is clear, let's see the solution. Now inside this, you will see that from here till um, here, you don't really need to worry about it. It is just my segment trees template. You can skip this. Like you can have your own template. The main thing is that I'm having a variable with name and, which will tell me about the and of the range for whichever I raise the query. And that's it. First of all, I'm just taking up the inputs. Then I created a segment tree for this given array, and then took the number of queries as input. And then for every query, I'm taking the left element and the limit as like limit is not a very good name, I guess here. Um, but this is the k which was being given to us. Since I'm having zero-based indexing, so that's why I'm reducing left. Then I'm starting a binary search. Obviously, the right element will definitely be greater than or equal to left. That's why the start range is left. And the end range can at max be n minus 1. It cannot be larger. And initially, I'm saying that my answer is minus 1 because like this might be the case that I don't get the condition true at any time. Then I've been yeah, I left management. It's actually because in the problem I'm being given this left as one based indexing and I'm having a zero based indexing. So just to uh, integrate them maybe, or you can just see that my elements are in the range from 0 to n minus 1, and according to the problem as they have been saying, it should be in the range from 1 to n. So that's why I'm doing this. And then I'm just searching inside this range. Answer is minus 1 initialized. Then just finding the mid, finding the and of this range from left to mid. If and then just checking that whether it is greater than equal to limit or not. If it is greater, then setting it to be my answer and searching on the right side, otherwise on the left side. At the end, just checking if answer is still equal to minus 1, then still like print minus 1. Otherwise, print answer plus 1 because I have to give the answer in one based indexing. So just incrementing the value by 1. And later on, at the end of the test case, I'm just uh, printing a new line. So I hope that the solution is pretty clear to you. Please confirm it once. Can you apply binary search without segment trees? There might be some way, but I think that using a segment tree is very like intuitive. You don't really need to write anything here. You just had to copy paste the code. Like I just copy pasted this code during the contest. Then I like added this line, this line, like not the complete line, but the section which I'm highlighting. Just added this, added this, and thus my segment tree is complete. Like segment tree is added. Then I could just use it very easily, and you don't really need to worry about anything either. Pretty cool way to use segment tree using PS. Yeah, segment tree with binary search is pretty cool. You've got to study this. Yeah, you can study about segment trees. It is pretty cool. Like even you don't even need to know about how it's working, even at the starting stage. And one of the best things is that this code is going to work since it is already tested. The code you write here might have some bugs, but that code is going to work. Yeah, you can copy my template. It is available on GitHub. You can check it from my GitHub. Mm, maybe, oh, time limit 5 seconds. So maybe it could have been brute force. I don't know about it, but I am just showing the like an intuitive way. This is quite intuitive. Even Grandmaster, I even saw Grandmaster doing the similar way. They just create a segment tree. It's very simple, and then apply a binary search. This is also not very hard. GitHub username. It's Raghav 14. You will like I will just give the link to the segment trees template on the in the description, or maybe you can just open up this submission, which you will find in the description. Then you can copy paste my template. So let's see the D problem now. Uh, D problem was a bit complex or maybe complicated also. With this, you will be given an array, not an array, but a string. This is a bit complicated, I guess. It is having some string, and there are some intervals. So like an interval like this, an interval like this, an interval like this, an interval like this. It was being given in the problem, and it was like as it was mentioned that the R of I will be equal to L of I plus 1 minus 1. So you should be able to, if you want to do problem like this, so at the very least, you should be able to think this much, that it was nothing but some intervals, this L and R, which were being given to us. And after that, we could have said, like we were being given some X, which will definitely lie in at like exactly one of them. Let's say that it is lying in this guy. So this Li plus Ri minus X and X. If you see this, it should have been clear to you that like for solving the problem, basically, for me, which the thing which I saw that if I am talking about this interval here and my X is lying here, then L plus R minus X is just at the opposite end. If it is the second element, then this will be the last second element. Just this much, just this thing, something like this. And since now we are having queries like this for reversing the string, the center is same. And if the center is same, then it doesn't matter in which order you reverse it. Like in a normal string, if I say you that you have to reverse this part and this part, then the order in which I say you to reverse, you have to reverse it on only that way. You cannot say that I will reverse this interval first and this interval. Otherwise, you will have different answer. But when the center is same, then it doesn't matter uh, in which order you reverse it. It will have the same result. So this is another property which I used, not a property but an observation. So the first observation was that the L and R which were being given in the input were actually forming some exhaustive and non-overlapping intervals, which will cover up all the whole string, and it has no overlaps. And like they are sorted also, they are being given in sorted order as well. The next thing was that this x and L minus like Li plus Ri minus x is nothing but it is just signifying that for any interval, if x is coming at any place, then Li plus Ri minus x will be coming at the mirror image or at the opposite place. Maybe if x was coming at this place, then this will be the other element, Li plus Ri minus x. You can try this out by taking some random examples and you will get this. So this is the first thing. This is the second thing. Now the third thing was this, that if you are having multiple string reversals, but the center is same, then you can even try to think about it making multiple cases that you will always have the same result no matter which one you choose first to reverse, which was initially not true in case if uh, they are not having the same centers. And like since the intervals are non-overlapping, so it might also have some reversals, like some other might also have some reversals, but they are non-overlapping, so it again doesn't matter which uh, one you choose to reverse first. So like the order of queries doesn't matter. This is the result we got. The order of queries doesn't really make any difference. It will still have the same result. And now you just had to do this. You could have been thinking about the problem as multiple intervals, independent intervals, like every interval is independent of each other. You have been given X in every query, and yeah, every query is also independent of each other, not exactly independent of each other. For multiple queries in the same range, they are independent, like they are dependent. But in which order you choose the queries is not dependent, like you can choose in any order. So, like for any query, let's say if it is coming inside this interval, so you can just create this taking all the queries for this interval separately. Then you can consider all the intervals for this queries, all the queries for this interval separately. Similarly for this one, similarly for this one. Okay. Now the problem has got a lot simple that you are being given an interval in which basically will be given some x, and this is gonna be, let's say, y. The other part, this I'm just defining y as the um, what to say, Li plus Ri minus x. This is the y, and like obviously y and x can be like this also. And now just to make sure that ln, like I want to have the one guy on the right and one guy on the left. I'm just saying that this is the mn and this is the mx, like the minimum of these two and the maximum of these two. Now I'm definitely sure that the mn will definitely be less than or equal to mx. Now my job is just this much, that I will be given some queries for this string where the center is same, so I don't really need worry about in which order I apply the reversals. I just want to apply the reversals, and after all the reversals, I want to find the final string in this interval, which I can do quite simply by saying something like this, that I can create maybe an array like marks. Yeah, some people are leaving, and I do agree that this problem is a little bit complicated, and maybe there might be some better approach. Uh, 1 mark. Difference array. Yeah, something like difference array. That's what I was going to say. That you can create something like marks first. As you saw, like as you got this query with having a mn here, you will just put up a mark here. And in mark, you just care about 0 or 1. You don't care about how many times this part is going to be reversed. You just care about whether it would be reversed or it won't be reversed. You know, like whether it would be reversed or not. Because if you reverse it 2 times, it is just equal to not reversing it. So you can just create a marks array and do something like marks of mn xor1 and marks of mx xor with like mx plus 1 with xor1, mx plus 1 with xor1, and at the end you will just find the prefix sum array or prefix xor array of this marks array, and it will tell you whether to swap this, like whether to swap the current element with the mirror element or not. And I know that this problem is looking a bit complicated. You must spend some of your time on your own first for this. How did you think of mx plus 1 or equal to 1? Okay, so for this thing, this is something very similar to difference array. Difference array is a standard technique, which is very similar to this way, where you have some queries, few queries on updation. You don't have to retrieve data, you just have to update data in the same way, like adding stuff or just storing with stuff. Here we have to XOR with one only for every query. So you will just, what we do for the range from L to R in the difference array is that say something like if the difference array is with name D, then D of L XOR equal to 1 and D of R plus 1 XOR equal to 1. Something like this we do. And at the end we say that for every DI, just do the XOR with the last element to find the prefix array, and you will get the final marks array, which will tell you whether you have to reverse or not. Hmm, I don't know why this problem got so complicated. Maybe my approach is not very optimal. If the arithmetic in the difference array is even, there is no need to reverse it, otherwise it will be odd and it will reverse. Yes, you are absolutely correct. If this element is having index, like at the end, if it is having a 0, it means that you don't have to reverse it. It means that you don't have to reverse it, and you can be very sure that both of these will be having the same value. Like this guy and this guy will have the same values. If it has 1, then it will also have 1. If it has a 0, then it will also have a 0. And again, something I'm just claiming. If you want to try to prove, you can try to prove, and it is something similar. Like simple, you can prove it. Now, after this much, what we can see is that for this interval, I will be having an array of something like ones and zeros, which will tell that if this is a 1, then uh, like this was the original string you had, original interval, and this is your answer. So we will say that hey, it has a 1. I will print up this guy here. So I will print up this guy here. Now for this, it has a 0, so we will just print up the normal guy. It has a 1, so we will print up the mirror guy. Or maybe you can just simply say that you will swap it with the last element. If it is a 0, you will not swap it with the last element. If it is a 1, you will swap it with the last element. And be careful that you have to go till the half of the string only. This is a better way maybe. And just doing this much for every interval will give you the answer. You will get your answer. And yeah, it got quite complicated. Many of you left. Let me show you my code. So the first thing I did was to take up the inputs like this. Instead of storing them in different arrays LNR, I just stored them inside a single vector. The order of queries doesn't matter because uh, The reason the order of queries doesn't matter is because if there is a query for this interval and if there is a query for this interval, uh, like it's already obvious that it doesn't matter whether you reverse this something in this or something in this, because they are non-overlapping, so they won't affect the output. And if you have to reverse, maybe you can take up two intervals in which the center part is same, then it doesn't matter whether you reverse this guy or this guy first. And it is true for any number of elements, any number of intervals which you have to reverse. If the center is same, then it doesn't matter which one you reverse first. So at the end, you saw that if the queries belong to different intervals, the queries are like already independent of each other, which one you resolve first. And if the queries belong to the same interval, in that case, the order of the queries doesn't matter. Like even now, uh, they could be overlapping intervals. No, in the problem they have like explicitly mentioned that this guy, if this is R0, and if this is R like L1, then R0 will be L1 minus 1, which means that they are not overlapping. They cannot overlap. This is true for all the intervals. And it is also signifying one more thing, that it is, let me say, it is covering the whole sub. It is covering the whole string. Okay, so now we have got to the answer actually. This much part is just taking the inputs, then taking the queries as input. After that, this queries, like I think you don't need to store the queries, or maybe, yeah, you don't need to store the queries. I just wrote it unnecessarily. This is the marks array I created for marking stuff, and taking up the queries as input, and then doing this part. Again, this was not necessary to directly store it inside X and decrement X. Then this is like a lower bound function which I wrote for finding in which interval X will be there, for finding in which interval will X come. And this is a simple lower bound function till here, where you tell about the starting end and the element which you want to search. But I was going to search inside a vector of integers, sorry, vector of integers, and I wanted to just search for an integer. So I wrote a lambda function myself. You can do, you can write this inside the lower bound function, like as we do in the sort function. And then I'm just finding the index of the interval, the number of that interval. Now, during by this, I just got the, like for this X, I just got its teammate. Now I'm saying the min and max to be the minimum and maximum of these two. And then I've been making up this change of marks of mn xor1 and marks of mx plus 1 xor1. But here the catch was that if mx is the last element of its interval, I don't want to make changes to the next interval. I didn't want to do this. So I just said this, that as I wanted to keep different intervals distinct from each other, I just put up a condition that it must lie inside X interval, otherwise just ignore. And then this DBG statement again you can ignore. And this is my answer array, like answer string, which I will be printing at the end. And here I've been going through the whole uh, all the intervals, like for every interval. Now for every interval, I've been first of all finding the suffix, not suffix, but prefix or array for the marks array, as we do in the array difference method. And then I've been declaring this reverse, which I never used. So you can again ignore this line. And now going inside this interval for every element, just finding its friend, like the mirror element inside the interval, and then saying that the index which I have to put up at this place for answer I is depending upon mark size. If mark size 2, then j, otherwise I. Like you can figure this out on your own. Like figure this much on your own and code it as the way you want to code it. I just wanted to keep short code, so I wrote this. And then I'm having this answer I equal to like this, just putting up the value and then at the end printing the answer. Okay, so shall we move on? Move on to the next problem. Okay, that's good. This is the if problem. I don't know why my submission didn't get accepted. It was getting some runtime error, which I could not find in the contest, and the code didn't work. But I can tell you about some observations which I noticed, since I'm not sure whether my approach was correct or not, as it didn't get submitted. I won't discuss it completely. What the problem said was that you will be given some variable, some integer n, and I guess this much only. Yeah, you will be given some integer n only, and there will be some queries. In every query, there will be two things. Like, first thing is going to be type. Type of the query can either be one or two. If it is true, it just means that reset, just come back to from where you started. Nothing special. Just say that your n, just make up your n to the original value which you had initially before any queries. And in the type 1 queries, you will be having an integer a or x, whatever it was, let's say x. Now what you have to do is just say that, hey, n into equal to x. Like your new n is the product of both these elements. That is n into x. And the task is, now you have to tell whether there exists any a such that divisors of n into a is equal to n. Whether there exists any whether there exists any a such that with which you multiply this n and you will get uh, the number of divisors of n into a is equal to n, and at the same time the GCD of n and a should be 1, which means that they should be co-prime. This is the task which you have to do for every query. Okay, so let me repeat it once again. What it says is that you will be given some variable n, some integer n, and there will be some queries. For every query, there can be two types, either one or two. If this is a type 2, then for now you can just ignore it. What you will be doing in this is that uh, whatever, like in type 1, we have been changing the value of n. In type 2, what we will do is just reset the value of n to the original value, nothing else. And now what we do in the type 1 is that we will be given an integer x in the type 1, and we will just say that, hey, now my new n is equal to n into x. And after that, I have to tell uh, whether there exists an a such that it is co-prime to n, and the number of divisors in n into a is equal to n. You don't really have to change the value of n, just tell whether it exists or not. Okay. For that, the thing which you could have noticed by looking at the constraints here, one thing is that the number of queries is not too much. Other thing is that x can be as large as 1e6, and it has never nowhere been mentioned that n into x, like what can be the maximum value of n into x after something. So we have to assume that it can be equal to 10 raised to the power 6 uh, raised to the power 1000. Yeah, there can be 1000 queries, and in every query you might be multiplying that number with 1e6. So it can be the maximum value, which means that you cannot directly store in. So this thing is, at the very least, this much is clear that you will be requiring something like a map for storing in. Let's say you have to store a value 24. You can store it easily with in this way. 3 raised up like 2 raised to the power 3 into 3, which is nothing but 8 into 3, and which is equal to 24. So we will be storing it in this way inside a map. This prime number can be like must be less than equal to 1e9, as the value of n and x can never exceed 1e6. So it like prime number will definitely be less than equal to 1e6, which can be stored inside an integer range. And in the worst case, the maximum power which can go is something like uh, when you have something like 10 raised to the power 6, it is 2 raised to the power 20, around that. So even in the worst case, you can have 20 added, like 20 into 1000, something like this. So even in the worst case, the maximum power can never be greater than 20,000. And basically, I was just showing that if you store it inside a map, it won't cause any trouble. So for any prime number, it will store its power. Simple enough. Now, can this help you to find the number of divisors? If you talk about 24, how many divisors does it have? It's like 1 into 24, 2 into 12, 3 into 8, 4 into 6, and just the other stuff. Now, this is nothing but this. It has 8 divisors. Could you say one thing that for every like 2 raised to the power 3 and into 3, could you say that for this 2, you have 4 choices? Either you have 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3. Like if you talk about combinatorics, just finding out all the divisors can be done using this also. For 3, it is having 2 choices, either 3 raised to the power 0 or 3 raised to the power 1, which is also giving 8 divisors. Let's take another example, maybe like 36, or maybe let's take 25. It is nothing but 5 square. It has 3 divisors, 1, 5, and 25. Are we getting the same thing? Yep, we are getting same thing. 5 raised to the power 0, 1, 2. And for 36 also you can try 2 raised to the power 2 into 3 raised to the power 2. And it's having 3 and 3, 9 divisors. So it's working proper. It's working fine. Right. The main idea was this guy, like the main idea was this much only, that you can find the number of divisors like this. As much as I know, it should be correct. And uh, if we can find the divisors of n, and now we have to tell if there exists any a such that n into a. Oh yeah, one more thing. When you have this n and you multiply it with some x, do you really need to multiply it? No, you don't need to multiply it. What you have to do is just prime factorize this x. Maybe if it was 24, then just say it to be 2 to the power 3 into 3. And inside the map which you created for this n, just go to 2 and add on 3. Go to 3 and add on 1. That's how you will multiply the elements. So you can just create a mul function, like multiply function, in which you will pass on a value and it will do it for you. For finding the number of divisors, you can create a get divisors function, which will like map will be given under, and it will just return you the number of divisors. You don't need to worry how. Now, just let's take an example. If the number is 140, if n is equal to 140, uh, we want to have 140 divisors for some number like n into a. The current number of divisors of n is 12, and the numbers which you can pick for a, like since a is co-prime, so we can try to understand it like you can. It is just some stuff like 140 can be written as It can be written as 2 raised to power 2 into 5 into 7. And then you can say, just a minute. Yeah. So you can say this stuff as, like you can just see that there are 3, 2, and 2. 3, 2, and 2. There are 12 divisors. And as A should not be any of them, A should not be any prime factor, it should be a different prime factor. So whenever you add any prime factor, you will just add 12 extra divisors. You will just have 12 extra divisors because you got 12 more combinations. So in a nutshell, n star A, like n into A, the divisors of n into A will always be a multiple of divisors of n as GCD of n and A equal to 1. Equal to 1, yeah. So we got this much. Now it's not hard to find the number of divisors of n. You can find it easily. We have even created a function, like you can easily create a function as discussed, as we discussed the logic here. With this logic, you can create the multiply function for every query. You can just now check that for this divisor, like this, sir, we have got the divisor of n here. Second, I think I'm also getting confused, I guess. Uh, okay, so it was this. We have been adding 12 every time. It was something related to this. And this part, I'm not like, I don't really remember it properly now. Uh, the relation I found. Let's leave the stuff which I'm not sure about. I will just give a link of a working code in the description so you can check it out. We have discussed most of the portion which I believe that is correct, and there is some portion left, some final touch for the, like, with the result of all these things. And right now I'm not completely sure whether it's correct or not, so I'm not discussing it here. And for the code which I wrote, it's not correct. It got some runtime error, and I don't know why. Here, what I did was to create a function for multiplying, created a function for divisors, created this auto, like, is valid function, which right now I'm not sure if it's correct or not. So that's, we have skipped this part. Like, this is just one function which we also have to create, and obviously stored the original value, as we will be going to come come back to it later on. Initially multiplying n for the map. Basically, whenever we are saying multiply the number, we are actually multiplying, uh, we are just adding its factors to the map. Initially added the factors of n to the map, then taking the input, taking the type query as input, and checking if it is type 2, then just say that, hey, n is equal to over 2. Just reset the value of n and clear the map and multiply it with n. Otherwise, if it is a type 1, then take input as x, multiply it, multiply the map with x, and get the divisors of this new number. And this was just for debugging purpose. And we have left this is valid function, like, we have not covered this is valid function as I'm not sure about it right now. According to the logic I wrote at that time, it was just about checking the divisors. So I think it's not correct. Not sure about it now. Okay. And basically, is valid function is something I'm not sure about, but I will give the link of the solution of some solution as soon as I do it. And just printing out yes or no on the basis of that. So that's what the problem was. Problem rating of all problems. Let's see some problems. The first one should be 800 rated, I guess. The second one also deserves to be 800, 900, something like that. Third one, third one. Yeah, again like 800 to 1000, or maybe 900, 1000, something like that. This reverse madness. This one, I guess, can be around 1600 to 1800 also. According to the solution which I made, it can be around that range. And for the E problem, can also be in the range from 1400 to 1600. And for the F problem, it can be somewhere around 1800, I guess. Um, During the contest, I got some work due to which I could not spend much time and was not active during the middle part of the contest. Otherwise, this was also doable. And for the G problem, I don't have much idea about it. It was pretty hard. Okay, so for the people who have been watching this video on YouTube, please give your valuable feedbacks in the feedback form. You will find it in the pinned comment in the comment section. And if you like the session, if it helped you, if the PCD helped you, then please like the video. And thank you for watching the video.